So in this video, I'm going to go over the 3 examples you were asked to do in this reading summary. And the first was to provide a truth table for the statement, if P and Q, then P or Q. And again, the two basic simple statements you have are P and Q, although you don't know what they actually represent. But so you have every truth combination of P and Q together. But there are intermediate steps that you should take before coming from these two to this. So we're going to make some room here and extend the table a bit. I'm first going to figure out for P and Q, which is one that we've seen a number of times already. And as mentioned before, for P and Q to be true, both P and Q have to be true at the same time. If either one of them is false, or if both of them are false, it's false. And that's why you have true, false, and false for the truth table for P and Q. P or Q, which is the second part of this conditional statement, again, it involves P and Q, but for this to be true, only one of the two have to be true, or both have to be true. So as long as one of them is true, it's true. The only time it's false is if both P and Q are false. So that's why I have true, 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 and false for the truth table for this. Now I have the if part. I know as hypothesis, they know it as the antecedent, and the conclusion is on the right side, or they call it the consequent. Basically, the truth table for this, if you remember, the only way this will be false is if this part is true and this part is false. So for this here, the first one, it's true because the condition's true, the result is true. For this one here, as soon as the condition becomes false, which is what it is for these next 3, this is automatically true, because once the condition's true, then whether or not the result occurs as expected, it's really, there's really no expectation of it. So whether it happens or not, it's still considered to be a true statement because the original condition hasn't been met. So this logical statement here has all true statements. It's just looking through the material so far, I don't know if they mentioned it, that this would be considered a tautology, which means it's a statement where all possibilities of it are true. But that's what you get for this one. Now for the second one, it looks very similar, except now I have the I have the union, or the disjoint, disjunction here, and I have the conjunction on the conclusion side. But again, I need to look at the two parts. I'm just going to kind of go through them quickly because they're the same two parts. I just have them listed in a different order. So nothing should be unfamiliar here. The other thing that's different now is that this is the condition, this is the conclusion. So if the condition is true and the result is true, this is a true statement. If the condition is true but the result's false, it's a false statement. If the condition is false, it doesn't matter what the result is, whether it's true or false, it's considered to be a true statement. And there's your truth table for this. So two very different truth tables just by simply, switching the left and right hand sides of a conditional statement. Now the third one had 3 variables, but it was also a biconditional statement. So again, I'm going to spread this out a little bit because I got to take it in its parts. The first part I'm going to look at here is P and R. Now P and R, again, for this to be true, both P and R have to be true at the same time. If it's not, then it's a false statement. So that's why I end up with true, false, and everything else after that's false, because there's only 2 instances where I actually have both P and R being true in this list here. So I had the condition down. I'm going to work on the result. The result, well, first I need to know what not P is. So, I'm going to do not P or Q. But I'm just going to figure out what not P is first. And not P is just me reversing everything I see in P. Now, with that being said, for this union to work, here we go. For the union to work, basically it's showing up true. These true and false statements are showing up. anywhere where one of these two are true. So this was true, which is why it was true over there. Here I had both of them being false. And from here on out, not P was true, so regardless of what Q was, it's going to be a true statement. Now, I have the two parts of this biconditional statement. The only way to be a biconditional statement, or an if and only if statement for it to be true, is if either both sides of it are true at the same time, or both sides are false at the same time. Because, and as I mentioned in the reading summary, a lot of people confuse an if-then statement with an if and only if statement. If I say, if you get all A's on your report card, I'm going to buy you a car, people think automatically, okay, if you don't get all A's on the report card, then you're not going to get a car. Well, that's not logically sound. That's logically sound if I said, I'll buy you a car if and only if you get all A's on your report card. Now that means that one cannot happen without the other. If I just say, if you get all A's, I'll buy you a car. I can still buy a car for that person, maybe for another reason, even though the condition of them getting all A's on their report card doesn't happen. So getting back to this, both are true here, so that's a true statement. As you go down the line here both are false, so it's a true statement. Everywhere else, I either have one being true and one being false. And that's why I only have two true statements for this, and the rest are false. And that is the end of this video. If you have any further questions, please make sure to reach out and get a hold of me. Until next time, have a good day.